Welcome you all. In this session, we are going to discuss in detail about the subroutine concept in Intel 8085 microprocessor. Expected outcome: after successful completion of this session, the student could able to explain the concept of subroutine in 8085 microprocessor. Subroutine. A subroutine is a group of instructions that will be used repeatedly in different locations of the program. Rather than repeat the same instruction several times, they can be grouped into one program, which is called subroutine. So if we want to repeat some task and whenever we need it, what we can do is we can group the set of instruction and set some memory location, and we can we name them as subroutine. Whenever we need to do that particular task, just we need to call that particular memory location, so that memory those sequence of instructions will be executed. So after that, with the help of return statement, we can come back to the main routine. So that is main routine, and the things which we copy to do repeatedly, we call them as subroutine. Okay, so that is what we call them as subroutine. When the main programs call a subroutine, the program execution is transferred to subroutine. After the completion of subroutine, the program execution returns back to main program. So the processor uses the stack to store the return address of the subroutine. So here the stack is utilized to store the return address back. So when the pointer moves to the subroutine, so now initially the previous address that executed will be there. After that, the next address to be executed in the main program will be stored in the stack, and after successful completion of subroutine, again with the help of stack, it returns back to the main program with the help of the memory location stored in the stack. So now there are two instructions which deals with subroutines. That is, with the help of two major instructions, we go for subroutine. One is you need to call that subroutine. Second thing is, once the subroutine is completed or accomplished, you need to return back to the main program. So with the help of return instruction. So these are the two major instructions which plays a major role in subroutine. So now let us discuss in detail about the call instruction and the return instruction. So this is the subroutine process. Here you can see the main program. So in main program, it will execute. So when a call subroutine is there, so there will be the address of this subroutine. So this is the subroutine instruction which need to be executed. So now you can see, now here I need to call the instruction. So automatically the program pointer moves to this point location and it will execute this. On successful execution of all the instruction in this subroutine, then again it need to return back to the main program at this point. So now with the help of stack, it retains this address value and it comes back to this point. So again the same execution takes place in the main program. Whenever again here at this point I need to call the subroutine, so it moves back again, it executes all the subroutine instructions, it come return back to the main program. So the process goes on like this. So the call instruction, so it's called 16-bit address. So this is how you can give. This is the unconditional call, and there is conditional call instructions also. Let's discuss that. These are the conditional call instructions available in Intel 8085 processor. See here I have tabulated, or I have noted all the call instructions, and with respect to and corresponding flag which is used or which indicates the condition is also noted over there. See the first one, call carry. So it will be called only if carry arises. So it always checks the carry flag, and if the carry flag is set, then the call instruction will be executed. So the particular subroutine program or the subroutine will be executed and then it will be returned back. Okay, so the second instruction is called no carry. If there is no carry, then what need to be done? So like that you can do. Next one is call positive. If sign flag is 0, then it is positive. If it is 1, it is negative, right? So now the next one is call minus. Next is call 0, call no 0. So these two, for these two instructions, the 0 flag, with the help of 0 flag, it checks. And the next two instruction is carry, call parity even, call parity odd. So even or odd, based on the parity flag, it can be done. Next is return instruction. So unconditional return, directly you can give RET instruction, or else there are certain conditional return instruction also. So here I have noted all the conditional return instruction and their corresponding status. So here the status is attained from the flag register, status flag, and here first I have coded the return carry. So it checks the carry flag. First two instructions, the return carry, return no carry. The next one is return what, positive or return minus, plus return minus. Next is return 0, return no 0, return parity even, return parity odd. So the parity, 0, sign and carry, these four flags are utilized to use the conditional return instructions. Thank you.